Welcome, everyone, to today's explainer on RESTful Services. As we map out the landscape of modern software engineering, understanding exactly how systems communicate over the web is absolutely vital. Today, we are focusing on an architectural style that has literally revolutionized web services. This is the backbone of the apps you use every single day. So, let's dive right in. Here's our game plan for today. First, we'll look at the problem with traditional web service standards. Then, we'll introduce REST, explore its core philosophy that everything is a resource, and map out how CRUD operations apply to HTTP. Finally, we'll cover JSON, statelessness, and wrap everything up with a crucial exam summary.
All right, let's kick things off with Section 1, the problem with web service standards. We really need to look at why a new approach was so desperately needed in the industry. Remember, in our previous discussions, we covered traditional standards like SOAP and WSDL. Well, the big issue there is that they are incredibly heavyweight. They rely on exchanging these massive, complex XML messages filled with textual tags. Creating and parsing those detailed XML envelopes requires serious processing power and a ton of bandwidth. So if you're dealing with a modern mobile device or a high-throughput system, this heavyweight standard is simply too slow and inefficient. It just bogs everything down.
And that brings us to a very natural question, doesn't it? With the mobile market absolutely exploding, if traditional WS standards are too heavy and inefficient, is there a lightweight alternative out there? How on earth can we allow systems to communicate without dealing with all that immense processing overhead?
Which leads us perfectly into Section 2, introducing REST, our lightweight solution.
REST actually stands for Representational State Transfer. I really want you to recognize the name of its creator, Roy Fielding. The absolute genius of REST is that it doesn't try to reinvent the wheel. It doesn't create complex new messaging protocols. Instead, it relies on the existing, fundamental protocols of the web itself, specifically HTTP. It's a lightweight alternative that simply transfers representations of resources from a server to a client. It's beautifully simple, incredibly fast, and completely changed the game.
Moving right along to Section 3, everything is a resource. Now this requires a bit of a mental shift.
In traditional programming, you probably think about calling methods or functions, right? Like calling a function named getTemperature. REST completely shifts this paradigm. The fundamental element here is a resource. A resource is simply a piece of data. It could be a document, a user profile, a university catalog, or weather data. And here's the absolute most important part. Every single resource is uniquely identified by its own URL. Now, a really common mistake students make is thinking they still need to command the server to perform an action. In REST, you don't send commands. You simply interact with the data directly via its specific web address.
Think about any general piece of data, a resource. There are really only 4 fundamental actions you can perform on it: create, read, update, or delete. But when we map this to the web, instead of writing custom methods for every single action, REST brilliantly uses the standard verbs that are already built into the HTTP protocol. We're talking about post, get, put, and delete.
Okay, pay close attention here. Section 4, mapping CRUD to HTTP. This is a crucial concept that you will definitely see in your exams.
CRUD stands for Create, Read, Update, and Delete. These are the 4 foundational operations you perform on data. In a RESTful service, these map perfectly to HTTP verbs. First, to create a resource, literally bringing it into existence, you use the HTTP post verb. Second, to read a resource, like returning a representation of it to your mobile screen, you use the HTTP get verb. Third, to update or change the value of a resource, you use the HTTP put verb. Now here's a quick tip. A very common mistake is confusing post and put. Just remember, post brings something brand new into existence, while put changes something that is already there. Finally, to delete a resource and make it inaccessible, you use the HTTP delete verb.
Let's look at some practical examples to see exactly how this works in action. Say an application wants to know the weather in Boston. It simply sends a GET request to the unique URL identifying that resource, which ends in /temperatures/Boston. The server reads that request and returns the data. But what if we need more specific data? Look at the second bullet. We add what's called a query string, date equals 2014-02-26. This specifically asks for the temperature in Edinburgh on that exact date. And finally, the third bullet shows how we disambiguate requests. There might be multiple Bostons in the world, right? So we use date equals and country equals USA. This clearly identifies exactly which resource we want to read. To quickly recap, every resource has a unique URL, and we manipulate them using those standard HTTP verbs: post, get, put, and delete.
All right, let's look at the nuts and bolts in Section 5, JSON, statelessness, and design trade-offs. A massive difference with RESTful services is that they heavily rely on JSON, JavaScript object notation, rather than XML. Why? Because JSON is vastly lighter to transmit and so much faster for a computer to parse. When a mobile phone asks for data, receiving it in JSON helps minimize the overhead and completely avoids the heavy processing required to decode those older, clunky XML messages.
Next, we arrive at another highly testable concept, statelessness. First, let's define it. In a RESTful architecture, services must be stateless. This simply means the server never, ever stores any session state or history about the client. Every single request you send from your phone to the server must contain absolutely all the information the server needs to understand and process it. Now, a very common misconception here is thinking stateless means the system doesn't use a database at all. That's not true. It just means the server doesn't remember your specific session history in its active memory. Every single request has to independently carry its own context.
Of course, as software engineers, we have to evaluate the trade-offs of every architecture. The pros of REST are pretty clear. It's highly mobile-friendly, it has lower overhead which results in much faster performance, and it's super simple to implement with existing websites. However, the cons are just as important to understand. REST lacks strict standards for interface descriptions. There's no equivalent to WSDL here, meaning developers often have to rely on informal, written documentation just to figure out a program's behavior. Additionally, it lacks built-in quality of service or QoS guarantees for things like reliability and transaction security, which SOAP-based services absolutely do provide.
And because of these trade-offs, we actually see a really interesting compromise in the real world. Major tech providers like Google and Amazon often offer both RESTful and SOAP-based APIs. This gives developers a choice. A developer might choose the RESTful API for a really fast, lightweight mobile app, but then switch to the SOAP-based API when strict transaction reliability is absolutely required. So to recap, REST favors fast, stateless JSON communication, but it does sacrifice the strict built-in reliability guarantees you get with SOAP.
And finally, Section 6, our exam summary. Let's lock in exactly what you need to know to ace your tests.
Take a screenshot of this slide or carefully write down these definitive bullet points right now. Number 1, REST is your lightweight, HTTP-based alternative to those heavyweight WS standards. Number 2, the core philosophy is that everything is a resource, uniquely identified by a URL. Number 3, know your CRUD mapping perfectly. Create is post, read is get, update is put, and delete is delete. Number 4, JSON is preferred over XML because it is much faster to parse and lighter to transmit. And number 5, statelessness. You absolutely must be able to explain that the server never stores session state. Every single request must contain all the necessary information.
And that brings us to the end of today's explainer. You should now have a really solid understanding of the mechanics behind how modern systems communicate. Next time, in Section 18.3, we're going to look at service engineering to see exactly how we build these reusable services from the ground up. But until then, I want to leave you with this thought. If REST was the lightweight answer to a heavyweight web, what happens when our mobile devices become even more powerful than the servers of yesterday? Will REST remain the absolute king of architecture, or is another revolution just around the corner? Thanks so much for joining me today, and I'll see you next time.